How does position in a series circuit affect current strength? Current strength refers to how quickly the electric charges are flowing, how many groups of charges flow past a point in a second. We measure current strength with an ammeter, which we connect in series, and it gives its reading in amps or milliamps. To answer this question, here we have 3 circuits. Actually, it's only one circuit with the ammeter in 3 different places. In all 3, there's a 9-volt cell, an LED, a 1K resistor, and a 10K resistor. And in all of them we have an ammeter busy measuring current strength. But the ammeter is measuring current strength at different places in each of the 3 circuits. In A, it's measuring current strength near the beginning of the circuit, we could say, near the positive terminal of the circuit. In B, it's measuring current strength in the middle of the circuit, between the 10K and the 1K resistors. And in C, it's measuring the current strength near the end of the circuit. Before we continue, you need to predict where do you think that the current strength will be the greatest? In the beginning of the circuit, the middle, or towards the end, or maybe all 3 will have the same current strength. What do you think? Before I give you the answer, let me give you a hint. Let's imagine that here we have a groove made of wood, or you could take a pipe and cut it in half, so that we've got a place where the marbles here can lie nicely. And we pack these marbles into this groove so that there's no space between any of the marbles. Every marble touches another marble on either side of it. So here we kind of have a chain of marbles. If I push one of these marbles, all of the marbles are going to move. Why? Because the one that I push touches the other one, which touches the other, and so on. So they are touching one another, and that's why when one moves, all move. But now I want to know, where will they move faster? Will more marbles move past a point every second near the place where I touch, let's say here, or a little further, let's say here, or maybe in the middle there, or towards the end there? Where will they move the fastest? Which marble here will move the fastest? Can you see that every marble has to move just as fast as every other marble because they're all connected by touching one another? So it's impossible for one marble to move faster than another, because if it would have to overtake the others, and there's no space for it to overtake. They're all connected by touching one another in this groove. This is similar to a series circuit. In a series circuit, all the components follow one another, and those components are all full of charge, electric charge. We could say electrons. And some of those electrons can move. And when the battery pushes, when the cell pushes, then those electrons which can move. The charges move. But they all move just as fast as one another because they're all part of a series circuit and they cannot be compressed. They cannot be squashed at one place and stretched at another, just like these marbles cannot be squashed at one place and stretched at another. They are incompressible. Electrons are also like that. They are incompressible. You can't squash them closer together in one part of the circuit and stretch them out at another part. So if one part of a series circuit is made to move, all the electrons everywhere have to move at that same rate. They all move together. And that is indeed what we find. Here you can see the readings that I took in these 3 circuits. Remember, all 3 circuits are actually the same circuit. The ammeter is just at different places in the circuit. In my circuit, the current strength was 0.69 milliamps wherever I measured the current strength. The symbol for current strength is I. We can call the current strength at the start of the circuit, the one that I measured in A, I1. The one at the middle, I2. The one that I measured in circuit C, I3. So for the same series circuit, just for different positions in the series circuit, I1 equals I2 equals I3. So let's answer our question. How does position in a series circuit affect current strength? And we see that it has no effect Position in a series circuit does not affect current strength. Or put another way, current strength is the same at all points in a series circuit. I1 equals I2 equals I3. And that's not surprising because all the electrons in a series circuit form an incompressible chain, just like these marbles do. Push them at one place, they all move together everywhere around the series circuit at the same rate, at the same current strength.